I believe all of us we know about matrices. Eugene, are you around? Are you part of us? Eugene, are you part of us?
Yes, please.
Okay, I believe you know about matrices. When you talk about matrices, you know it.
Please, yeah.
So matrix is all about it's just a table of or grid of numbers. And a table that contains just rows and columns. And when you watch the matrix I'm displaying here, you have two rows and we have two rows and three columns here. Two rows and three columns. And now I just want to do something like this. Why do you want to use matrix? We want to use matrix because we can express the calculation that go into working out the combined modulated signal x into each node of the second layer using matrix multiplication. Because what you did previously, I don't know if you guys were able to the previous class, you're able to get how to find our modulated signal x. How to find our modulated signal x. To find a modulated signal, you have to just multiply the input by its corresponding wavelengths, and just sum it into that node. So that's why I'm just saying our combined modulated signal x. And we can just do that using matrix. We can do that using representing it by matrix. And that's what we want to do today. So let's see, before that, let's see how we can do matrix multiplications. We must multiply two matrices together, or to find a dot product using two matrices. We must take the first row and multiply by the first column. So multiplying two matrices, just take the first row here and multiply by the first column here. And next one, so you have to just take the second row here and just multiply by the second column here. And you see how they are doing it. So the first row multiply by the first column, you're going to do something like 1 times 5. This 1 times 5 plus 2 times 7. If you give it a value here. When you take the second first row again, multiply by the second column here. And this calculation will be done like the same thing 1 times 6, 2 times 8. Just write the value here. If you get a value here, you have to take this one, but this the one below here, 4, that's the second row. Multiply by the first column. And that value will be here. Let's take the second row here again, multiply by the second column. And that value will be here. So this is how we do our matrix multiplication. Yeah, matrix. I know you guys already know it, but I just have to refresh some stuff on it. Matrix multiplication. So for us to do this thing, what we are supposed to know is that you just have to know some things here. The things that you need to know is that I represent our input from the input layer. When you see I just represent input from the input layer. And when you see something like X hidden is just the input into the hidden layer. Because we will be dealing with really, let's say, our input layer, our hidden layer, and our output layer. So if it's something like X, anything X means it's an input, and the subscript tells you which layer it is. So you can see that I have X, then the layer F subscript is hidden to mean the input of the hidden layer, and X subscript also mean the input of the output layer. But anything like O is just about output. So O subscript hidden means like output from the hidden layer, and O subscript output means the output layer. So these are some things that we should just know is awkward. Like once you're just trying to do the matrix convection, there's some things you should just know. You can just take on 2 minutes or 3 minutes, just try and just see this thing so and then yeah, and their meaning. But we'll be using it a lot. So moving ahead. So you can just want to see when you have something like this, it's a two-layer neural network. It's a two-layer neural network. And you have this input layer, you have an input layer here. Is it?
Okay.
Waiting them,
I said you can
waiting
continue.
something.
I'm following.
So this is a two-layer neural network. Mm,
I said you can continue. I'm following.
okay. So this is a two-layer neural network. You just want to convert this into what? Into the matrix multiplication. And we said the first thing we need to do is just the most important thing we have to do is just to get our input. You have to get our input values. And when you watch this one very well, watch this one very, very well, you can see the inputs coming here say A and B. These are just A and B. This is the input that's coming here. And these are weight links. And this weight link, they have to be on the same way. They are the weight link entering to this node here, will be on the same row. And see this node here. This node here, the weight link coming to is this one and this one. And see the
Okay.
weight coming to
So,
just
hello.
yeah, I'm listening to you.
So, per comparing it to okay, the previous ones, that one we were considering the one you showed us first before moving to this slide. That one you're showing us three layers, right?
Yeah, that was 3 days. But it's just 2 days.
Okay.
So
I
what
was
we
I was
need to mostly
getting
do is just to
confused
keep
on
this
that one.
input in just one. So we keep the input values here in one matrix, then a weight link here. Also keep it in another matrix. But the most one thing you should just have to know here is that just when you just check it well, you can see the A and B. The A and B from the previous slide, there is just the input. The inputs there here, you can see the value is just A and B. And when you check the matrix notation, you put them in just one note, a vector here, like a matrix. It is a matrix, but it's just an n by one matrix. As we put them in just one matrix, A and B, like what you're seeing, A, B, we put them to one matrix here. And see the link weight here. You can see the link weight. When you take the first node here, we are not using this one because this one just represents our input layer. This one represents our input layer because just take the value from the input. And when you watch here, you can see this node here. The links coming to this one is just W11 and W21. Is W11 and W21. So those ones coming to this one, they'll just be on one row. You can see W11 and W21. Let's see something. So W1 and W2, you can see they're on the same row here. See, I want to take a second node here, the second node here. You can see the links coming to this one too. W1, 2, and W2, 2. They also be on the what? On the second node here. So W1, 2, they also on the second node here. So all the links.
Hello. Hello. I'm not hearing it. Is it from my side or?
It's not from your side because I can hear you.
Okay. Welcome.
Yeah, yeah. Can you guys hear?
Sure, sure.
Grace, yeah, Grace, can you hear me? Malcolm, can you hear me?
Yeah, I can hear you. So this is the metrics way, right?
Are you
Yeah,
Ikechukwu?
yeah, I am. I just used a different email
Oh,
to
okay.
join.
Alright. So we're just trying to convert our neural network to matrix notation form.
I didn't hear you.
The calculation we did the other time, the fit coding calculation, we're now trying, we want to use matrix to do it.
Oh, okay.
So they gave us this is the network we used. We use this network and we matrix. We use this network here and convert it to a matrix. That's how the calculation, and that's how you form the matrix here. We will just have to take the input here and put it in one matrix. We put it into this one. And you come here, we just take this node here, the length connecting to this node. The length connecting to this will just be one row. And we take in the second one here, the length connecting to it will also be in another row. So that's it. That's it. If we should, when I'm done, just have to apply the segment function to it. So if we should have like 2 or 3 layers to our, the only thing we're supposed to do is just get our input. Then we have to just first the link with that connect like the first layer to the second layer. No, we have to put it in one matrix. And go to the other one. The link will connect the second layer to the yeah, without put it in another matrix. If you have 10 layers, you can still use the same idea. You can still use the same idea. You can do the matrix multiplication for all the layers. If you don't understand, let's take an example again. So when you see this example here, this is just a two-layer neural network. This is a two-layer neural network. And one thing is what I said, the first thing is just the first matrix is just our input layer. It's our input matrix. Here you can see you have 2 here and you have 1.5 here. We just have to put it in one matrix. You can see they put in 2 here, they put 1.5 in one matrix. That's our input matrix. Then with us to find a weight matrix, we take this node. You're not taking this node because this node here, they are just representing our input layer, and we're done with the input layer. This matrix here just represents our input layer. You just take the value for it. So we are not going to bother ourselves with this first layer again. We just go to the second layer. With the second layer here, for us to just the reason you're supposed to, because we know it's this one, the inputs coming to this one is always combined. It's a combined moderated input. Combined. So we just have to take each link weight. The link coming to this here, you can see is this link here as 0.4 and this link here is 0.6. And those two links coming to this here will just be on one row. That's why I've seen something like 0.4, 0.6, 0.4, 0.6. That's on this row. And the second node here, the length coming to it 0.2 and 0.4. This will be in another row. So 0.2, 0.4, this will be in another row. So that's it. So you have converted it into a matrix notation form. The only thing you have to do, just take the input layer. The input layer is just values. Just take its values here. You just put in one matrix form. Then it comes this way. The second layer here, just take the first node. The weight link coming to that node will be on one row. Second node, the weight link coming to it will also be on another row. And just put all of them in a matrix. And that will be the matrix for our weight lengths. That will be the matrix for our weight lengths. So that's what we just did. When I'm done, we just have to do the same thing. We have to multiply it. How we do our matrix multiplication. This one by 2 plus 0.6 by 1.5. When done, we just come to the next row. 0.2 times 2.
So can you repeat that again?
To do the matrix multiplication,
Okay.
this is how we do it. Mathematics, we just take this row here, multiply by this, because we have only one. This is an n by 1 matrix, or like a vector.
Yes. Yes.
You just have to take the rule here, multiply it by the value here. 0.4 multiplied 2, 0.4 times 2.0 plus 0.6 times 1.5.
Fine.
Then we add it
Yes.
together, and that will be the value here. The same thing too for the down one.
Zero
Take
point two
0.2
here.
multiplied by this 2, 0.4 multiplied by 1.5. And
Mm-hmm.
that summation just gives us this value here. You see.
Okay.
So when you get this one, this one, say this is our X hidden. Why are they saying X hidden? Because it's the input into a hidden layer. It's the input into this hidden layer, this node here. The input into this node here, this node here. But you're not done. This is just our activated. This is just our activated input. If you can, if you remember from our last previous lesson, we were talking about activated input. When you get these values here, what you're supposed to do, when you get these values here, what you're supposed to do is just apply the segment function to it. See, there's a segment function. So 1 over 1 plus e to the negative 1.7. The 1.7 is coming from this side here, this side here. So 1.7 is coming from this side here. Then the second one is the same thing, 1 over 1 plus e to the negative 1. And the 1 is just coming from this side here. So when you get this modulated signal here, just apply the segment function to it. And that will give us the output from that layer. That will give us the output from that layer. So the most important thing is if you're able to convert it to a matrix format, and you get the input into the layer here, you shouldn't forget to use the segment function to find the output from the layer. Find the output from the layer. So this time now, the other one we did with just 2 layers here. This time I'm going to deal with 3 layers here. 3 layers. And let me see from you guys how you also think about it. So what do you think will be the input matrix? What will be the values or the elements in the input matrix? It looks cumbersome, but you can just take it and just observe it well.
That's we have a 3 by 1 matrix. That's 3 rows, 1 column, where the first row will be 0.9, the second row will be 0.1, then the third row will be 0.8 in the same column.
Very good, exactly. That's true. So that will be there for the input matrix. That will be the input matrix for
Yes,
the input
please.
data. Right. So to get the next one is we are supposed to get the link weight. The link weight between the input layer and the hidden layer. Now we have 3 layers here. You have input layer, hidden layer, and output layer. So what's the link weight? What do you think will the link weight between the input layer and the hidden layer?
Come again, come again.
The inputs, the link weights, the link weight matrix between the input layer and the hidden layer. Because they know there's a 3-layer neural network, so you're going to get 2 weight matrix, 2 weight matrix, 2 weight link weight, 2 weight link matrix. One will be between input layer and the hidden layer, and another one will be between hidden layer and the output layer. Between. So I'm talking about the one between this input layer and the hidden layer. It's the same thing, it's the same idea, like what you just did here.
The same calculation. Okay.
It's the same idea. So yeah, I'm just trying to find a weight link between this one and this one. So to find a weight link between this one and this one, you just have to just take the value here.
The value going to A 0.9, 0.9, 0.3, 0.4.
That will be the first row plus 0.9,
That'll be the first row, yeah.
0.3. And the second row will be.
Then the second row will be going to B, so it will be 0.2. Then where's 0.2, 0.2, then 0.8.
It will rather be
0.2, 0.8,
0.8, then
0.8 and
0.2.
0.2.
You need to go accordingly, you see.
Is that correct?
Yeah, that's correct. So
Sure,
it needs to
sure.
be
0 point
0.2, 0.8, and 0.2.
zero
And
point
the
two.
last
So
row,
the
the last,
0.1, 0.5, 0.6.
that'll be the last row. So you consider the same thing here. That's the weight length between the input layer and the hidden layer. And when you're done, you have to do the same thing for the S1 too. The weight length between the hidden layer and the output layer.
So
So what's the value on the
in that case, will you use the output of the first the first multiplication with it? That's finding the output. Will you use that as an input for the next one, or you still
yeah,
maintain
that'll
that
be
0.9, 0.1, and
no, that'll be the
0.8?
You still maintain the 0.9 since it's for three of them. It goes for everything.
no. It's a feed forwarding. So after multiplying this one by 8 weights, we get an
Okay.
input into this hidden layer here. Then you apply the segment function to give us an output.
Okay.
And that
Okay.
output will
Okay.
now be used
Will
to do
serve
the
as
multiply this one.
an input for the last one.
Yeah.
So basically,
Let's see
the
it
the weight
multiply.
the weights plus this times that will be the new output.
The weight plus the link weight here.
Yes.
Then you apply the segment function to it. That will give us
So
an output.
then you use the
Okay.
output
So the
as
sigma
an
function
input
has
for
to
the
be
next
added to
layer.
it.
Yeah, to get the output, you need to apply the segment function to it to get an output.
Okay. Okay. I'd like to see an example though, so just to be sure.
But let's find the weight length for this one first. The link for this, the one between this and this.
Okay. 0.3, 0.7, and 0.5.
Right. So and the next one will be the next row will be 0.6, 0.5, and 0.2. And the last one will be
Yes.
0.8, 0.1, and
0.1,
0.9.
0.9. Yes.
So that's what you're seeing here. Now let's see how the calculation goes. So first, you need to find the input into this hidden layer. You have to find the input
Okay.
into this hidden layer. If you get the output for the if you find the input into this layer, you just have to take this one. You have to multiply this one and this one. This one and this one will give us the input into the hidden layer. It's not this one and this one because when you check this diagram here, the linkage between the input and the hidden is just the values here, but not this values here.
Oh, yeah.
That's why I multiply this one and this one. So when you do this multiplication, you're going to get the values here. You're going to get these values here.
Yes.
When you get these values here, this is just an
Then
input.
you
This
apply the
this
signal
this is,
function
this is
like
just an input. So to get the output from this hidden layer here, just apply the segment function. So this is just an input, the input here. Then you apply the segment function to it. Segment function, you already know, you just 1 over 1 plus here from the negative or the value.
double or the weight.
When you just apply the segment function, this will give us the output. And the output here, and this output here now serve as an it's just serve as an
Input
input
for the last layer.
for this last year. You have to use that. You have to use those values and multiply by the weight links here. You can see that when we took the weight link between the hidden and the output layer. By this time, see the input you are using here wasn't the one we used. Wasn't it 0.9, 0.1, 0.8.
Sure, sure.
But for this one, what you had from the previous one, that was from the hidden layer, that's what you're using. If you multiply it, this is what you're going to get. And these values you're seeing here, they're just the input into the output layer. They're the input into the output layer. And then you have to apply the segment function again. Apply the segment function again. And this time with this one will be the output for the output layer. This will be the
Okay.
output layer. And
So
this will be
so it means that in case we were to have four layers, this will serve as another input for the last one.
this will you use this value to multiply the weight link to serve as an input in the
Okay,
other
okay,
layer.
okay.
So since you are just dealing with 3 layers here, Our final output from the network of a neural network will just be this value still. Be this value still. Is it confusing or is it understandable?
Okay, it's
Do you
okay for
understand?
here.
It's okay. So let's just our final output and see. It just went step by step. This was our input. You multiply it by the link weight. Then it serves as an input into the signal here. If you apply the segment function, we had this value as an output. Then multiply by the link weight again. And this one give us these values and serve as an input to our output layer. Apply the segment function and give us the output here. Okay. Now, the what you just did, you can just use, I can just write this code very, very simple and just do it. And the rest, you can use like then just write this code and just see if you can also get an output like that. So to do that, let's just try and see if your NumPy is ready, your Jupyter notebook is ready. So let's try and keep notes of this one. I'll write it down so that when I'm typing it in a Jupyter notebook, to be easy. And just write or just take a screenshot so that you can just input it in a Jupyter notebook.
Come again. Come again.
And write these values down. You will be using it, this value, the input
Okay.
matrix,
Okay. Okay.
the weight matrix here and this one.
Okay. You have a screenshot of it.
So let's open Jupyter notebook. Let's open our Jupyter notebook. Can you see it?
Sure.
So if you can see it, let's see how you can go about it. So what I'm going to use NumPy to do it. I'm going to import NumPy. Because NumPy is good to do dimensional data, like dealing with matrices and arrays. So in NumPy, they refer to every matrix as an array, but you can still write it using the matrix notation form. NumPy.matrix. So to write the matrix in NumPy, in this Jupyter notebook, we use using the NumPy. The only thing you're supposed to do is just use the NumPy and call it the matrix function in it. But can you see it? I'm trying to increase the size.
Sure. Sure.
So that's how I used to write it. You have to just call the matrix function in NumPy. And this is how you pass the values. And see here you have comma, comma, then semicolon. Comma, comma, semicolon. Semicolon will always take you to the next row. Anytime you bring semicolon, it takes you to the next row. Takes you to the next row. So you can see I wrote 2, 2, 3. Then I wrote semicolon. You realize these 2, 2, 3 have been on the same row here. And then other ones it's on a different row. So you use semicolon, you have to separate it to go to the next row. So if you want to do something like that, let me just come here. Just
I'm still trying to open my Jupyter notebook.
All right. But Ransford, are you using a Jupyter notebook?
No, I'm going closer to my PC.
So I do import numpy, right?
It helps import them.
So my import numpy, my import is not turning green. Is it because? Is there any reason for that?
Import is not doing it.
It's not turning green like yours.
But are you right? But when you click on it, does it run or
Okay, I haven't. Let me click on enter. I'm still trying to write the code. Just
just write it and run it and let's see.
okay, I guess it's because my this thing wasn't set up yet.
Wasn't it?
My what do you call it? I didn't open it from my admin first. I just went to reload my former open page. So I actually had to go reload it.
Okay. So if you're not close to your machine, I can just observe it and let's move on.
So
So with
my
the
question
with the
is,
one
why it's like I'm seeing some quotations over there, which is giving us that red color 233 semicolon 245. So how will this the numpy know that we are not dealing with strings, rather normal numerical values? Because of the quotation mark, that's why I'm kind of
with
confused.
matrix when I do matrix you deal with numbers with matrix.
Sure, but it's like here we have our numbers in a quotation form. So I'm thinking maybe it's going to assume we are dealing with strings here instead of normal real numbers. I thought it would be something like numpy dot matrix, then you open bracket, you just write your 2 3 that thing instead
Yeah,
of putting it in
normally
bracket. That's what I'm trying
normally
to.
in programming, in programming we put strings in double quotation and just leave numbers just like that. Yeah, but
Sure.
with every program and every what they write in it, with this numpy, the particular criteria is said to for you to be able to
Okay.
use this matrix function in it, you just have to write something like this. So
Okay.
there's a
Okay.
syntax that goes with this matrix flow.
Sorry, how did you move to the output too?
Just click on shift enter to take you to the
I click on shift
set
here.
Or
point.
the run button.
Can you do one thing?
When I click on
Right,
shift, it's
so
not taking me there.
but
Please,
are you
he
running the
said.
server? Are you running the server?
He said.
No, I'm running it from the this thing from the web at the server,
So when you run
localhost.
at what happens when you run?
No, I haven't run it. Like I just did the NumPy metrics 2, 2, 3, 2, 4, 5. So I'm still on the your IN2.
He said enter shift plus enter,
So I'm
or
trying.
you just click on the run.
Shift plus enter.
Yes, please.
Okay, okay, okay. Shift plus enter worked.
So you're getting an output now.
Yeah, I'm getting an output.
So we can continue. So let's take what we're working on. So let's see. What the one we're working on, our input was 0.9, 0.8. So let's just try and convert this one. Let's say our input. Or let's just do it I. So it was 0.9, 0.1, and 0.8. So let's try and print this I and see something. 0.9, 0.1, 0.8. But the input wasn't, this. I believe, do you know column vectors and do you know row vectors?
What balance vector?
Do you know a column vector and do you know a column vector and also a row vector?
I've heard
Do
of
you know the
row
difference
vector. I
between a row
think
vector and a column vector?
no, I've never heard of column vector, but I've heard of row.
The one we were using was a row vector. The one we showed in the matrix notation was a row vector. So we can't just represent it in this form. We can't represent it in this form. So what you can just do, you just have to just either come here and just write this, bring semicolon after each number, or after each value, you have to bring semicolon, just so that you can convert it to a row vector here. Well, the one I showed you from the PowerPoint, it was looking something like this. It wasn't just straight. It was in this form, so vertical. So then we just go to our weight. Just go to our weight. So we just write weight input hidden. This input hidden. Then come here numpy dot matrix. The weight was 0.9,
0.9,
0.2,
0.3, 0.4,
0.3,
then the next line 0.2,
0.2, 0.8,
8, then 0.2 again.
0.2. The next line 0.1.
1, 0.5, and 0.6.
So let's try and print and see. Print W. Oops. Right, so this is what you're getting. So for us to be able to multiply them together, we can just do something like this. I can say, now when if we should multiply them together, it will serve as an input. It will serve as an input into a hidden layer. So I hidden. So I can just do X hidden. X is just an input. X hidden means the input into this hidden layer. And what you can do just go to numpy dot. Dot is just this. I what?
numpy dot bracket open. Okay, you are starting with the weight input hidden, then comma, then you bring your I.
So you can see that the weight rather count. When you're doing the weight was first before the input.
Okay.
So then print X
Print
hidden.
X hidden.
This is what you're getting. If you can remember what this was the value that came from the PowerPoint. We have a value like this.
Sure. Before multiplying it to the, before using the that function. Do it more
So the segment function, use the segment function, you have to import this. You have to import this. So you can use the segment function. To get the output, you just have to write O hidden. Meaning the output from the hidden layer. Once you come here, remember the SciPy, then our X hidden. print or O. Then
Okay, so
see the
we
value of
have
it.
to import the script special.
You have to import it scipy.special. You need to
Okay, so
import it.
all we just have to do is just write that. We don't need to run it.
Now, when you import this one, then come and call this function here. Then when you're done,
Okay.
you run it.
Okay.
It will run together. So this O hidden will now serve as an input into the next one.
into
So
the
before that,
next layer.
yeah, before that, okay, let's try and go to the next. Yeah, let's use the next cell to do it. Let's use the next cell to do it. So that you can see that it's not only one cell that I can use to do everything. I use the different cell to do it. But all the variables will be kept for us. We can come W. There's a weight link between the hidden layer and the output layer. So numpy.matrix. Let's see the values. So 0.3, 0.7, 2.5, 2.6, 2.5, 0.8, 0.1, 0.9, and 0.9. So this is the weight link between hidden and output layer. And to multiply them together, I can just say we have to use X output, meaning the input into our output node. The input into our output layer. The input into our output layer. That's just have to numpy dot, then our weight hidden, then our out, and the input here will come
O
this one.
hidden. The O hidden.
The O hidden. And when you're done, you have to come again. X, that's come O output. That's to come and call this function again.
Scipy dot special dot expect.
So then you have to pass the X output here.
Print O output.
We should print this because this is supposed to be our final answer. This is supposed to be our
So
final
that's the
output
final output.
from our neural network. And this one corresponds to what you just saw on the PPT or on the PowerPoint. So this, you can see how this NumPy is working out. It's helping us to, or this motor is helping us to do the calculation. If we should do it manually, you can see we should take a lot of time to do it. So as you're just going through this one, you're also learning a bit of Python through this. But this Python learning is more
Sure.
about it's more about some calculations and stuff.
Zero 0.3, 0.7.
So are we okay? We understand it up to this point.
Sure for this side.
Yeah?
I said sure for this side.
Alright. So you understand up to this point. So Mark, are you okay?
Yeah, I'm good.
Yeah, good. That's nice. But one thing I just want to show you guys is that if we should start doing with our neural network, and start doing with our neural network, you will not have any ways like this. With neural nets, because we don't know the exact weight that our matrix we need to use. Our matrix to use. So to create a weight link, to create a weight link, here's how we do it. We just do something like numpy dot random dot normal. And do 2, 3. And yes, no, actually, I'm not going to store it. I just have something like it. So when you start dealing with, when you start writing a neural network code, you're not going to write a code like this for a weight link. I am writing this one for you because just for educational purpose or just for you to understand how everything works. But you never have a neural network for you to just give your own starting weight link. Mostly
Okay.
we generate the values for our weight link randomly. We generate the value for our weight link randomly. And what this code really means is this is a mathematical statistical code for those who did like probability or measure theory. This
Mm.
value, this one is just like it means generates a random number for me. But that random number must have
Okay.
a normal distribution. That's the meaning of the code I've written. Generates random number for me. But that value should have a random distribution. It should have a normal distribution. And when you talk about normal distribution, meaning it's supposed to have a bell curve shape. Like the shape should be like a bell curve. If you want the internet, just talk about normal distribution, you can see like the curve of normal distribution. The curve for normal distribution is always like random. It's always like a bell, like a curve. I don't know if you understand what I'm saying. The normal distribution, you can see normal distribution curve. And see, have you seen the shape of the normal distribution?
Sure.
Can you see? They're all like they all look like a bell. A bell. They look like a bell. So this is how a normal distribution curve look like. And when you watch it very well, you see the center here. The center here.
Yeah.
Let me just do one shape here. Open this here. You see the spread, like you see the spread here. There's a spread. You see the inside the mid. You see the middle line. They've written a dot line here.
Dot dot
Dot,
dot. Sure.
and that dot line. See, there's a deep line on the left and deep line on the right. This one
All right.
shows you the
Yeah.
spread. It shows you the spread. It shows you the spread. And this spread is what is mostly referred to as our variance. They call it as your variance. I'm just trying to like get you know like the meaning of this random value you're using. So the values you've generated here, the values you have generated here, the values you have generated here is having a normal distribution. And what these two means is that the two tells us that they should be the mean of that normal distribution. They should be the mean of the normal distribution. And the standard deviation is this 3 here. The standard deviation is a 3 here. If you should square the standard deviation, it's going to give you the variance. The variance was the one I was showing like a spread from that midpoint.
Okay.
The mean is 2, and 3 is our variance. Because with every neural network, with how you want to generate it, some can use a new uniform distribution just to generate the random values, depending on what you're working on. Depending on what you're working on. And if I should just prove to you that this thing we generated here is having a normal distribution now, or it's having a bell curve shape, this is what you can do. You don't have to worry yourself about it. This is something I just want to just show you guys. So let me just try and reshape this values for you. I'll just come here and reshape the values for you. I just come here dx is equal to numpy dot reshape. Send numpy to reshape this values for me because I want them to have. Now this is in 2-dimensional. I just want it to be in
Sure.
1-dimensional. I want it to be in 1-dimensional. I want it to be 1-dimensional. So I just come here. Let me just do something like 1. Let's say 200. I come here before. Let me try and import this thing. Import plot lib py plot so as plt. So plt dot histogram. I want to put as histogram dx. See. So when I plot this well, the values I plotted is not really much. I can see the shape here is look like a bell shape, like what I was showing you, like something like a bell shape. So like how the bell looks like. See the values here, they're not mean. That's why you don't see so. When I keep increasing, you see this look like a bell shape, like the one we saw. It's a concept I'm just trying to guys.
How do you call it? You were having some when you were typing. You were trying to import the matplotlib library. I saw some IntelliSense, some autocomplete, something. Are you using an extension or there is something I have to do before getting those things?
When you're typing,
I'm
just
tired
when
of
you type,
writing it.
try and type that. Use the tab key. The tab key you have to give you the intelligence. The tab key.
Okay.
The tab key you have to get intelligence. So that's the meaning of the random. That's the meaning of the random that you saw. So to generate our weight, we have to use this. We're using this numpy or random normal a lot of the time. So if you have time, you can just go and read about normal distribution. Why we are using the numpy or random to do it. Alright. So if you have question or if you are good to go, we'll try and end a class here. And we continue on Sunday.
Why are you tired?
Oh no, I just spent 1 hour to teach this, and next I continue.
No. Okay. No
You can't do
problem.
everything today. So no question.
Thanks for coming.
Yep. Yeah, Mark, are you okay?
Yeah, I'm good.
Yeah, you're good. So see you guys on Sunday.
Right now, thank you very much.
Yeah, you're welcome.
Thanks for coming.